Hello and good afternoon. Good
Good
afternoon.
afternoon, sir.
Good
Good
afternoon.
afternoon,
Uh,
sir.
I'll share something. I'll upload something to this portal, which is of course not connected to the course, but that is a very vital report. Uh, I think you might have. This is just released, and you might have come across that. That in particular talks about the skill set. Uh, I mean, what skill set you must have uh, for the jobs and others. Let me share these things. Is it is it visible? This is a future job report 2020. Is it visible?
Yes, sir. Yes, sir.
Yeah.
Yes, sir.
So I'll be uploading these things.
Yes,
Why I am interested this when we plan our career or looking into the subject. Sometimes planning what are the courses I should pursue, how should I shape my study for the job point of view. I request key should go through that and look into the profile or jobs which are up to 2025 that are promising skill set, what is required, and moreover the technology which is dominating the job market. So this is a, I mean, if this is a, if you look into the title says future of jobs. So it's a must for you. Huh? So this thing I'll upload to the my course portal. Please have a look into that. There are a lot of interesting features you'll find country wise. Maybe you can look into if I'll search for the India. It will take a few seconds to get that one. Uh, So country-wise job profile and country-wise the jobs and most of the things is predicted for 2025. If you can find on your screen, this is United States profile and I mean how they are going to projected the skill which is required. You see the technology adoption is predominated with cloud computing and internet things and connected device, followed by the machine learning and neural network. But then there is another column which says emerging and redundant job roles. That starts with AI, machine learning, analytic, big data, IoT, and all those things. This is the information. I'll upload these things. Okay. So uh, this I will be sharing with the portal. Okay. Now we'll back to the our witness, that is we'll start with static hashing and we'll be continue with the dynamic hashing. Dynamic hashing mostly uses a data structure which is dynamic in nature, means you can say we can say call it as a extendable hashing. I'll take a minute to load. Yes. We talk about the hash with chain. This is a data structure where when we talk about the buckets are fixed. Buckets are fixed and slots are extending. But when we'll come to the dynamic hashing, the buckets are extending. Please remember, in case of dynamic hashing, which we'll be discussing last, then buckets are increasing. I mean, here I have got 26 addresses or the 26 buckets. I am extending the slots when I go for a hash chain or a dynamic data structure like linked list. But when we'll be entering into dynamic hashing, there will be increase in bucket. So predominantly, if you look into the basic difference between static hashing and dynamic hashing, static hashing is the number of buckets are constant. In dynamic hashing, the buckets are dynamic in nature. Okay, so here we are in case of the hash chain. I mean, the number of slots are increased up to a finite number of quantities. Sometimes it will go on increasing dynamically depending on the key that are entered to stored. That means if all the keywords or the reserve words or the variables that starts with A, so this list is elongated. Now let us look into a particular C program you have written. You have defined variables like A, A2, A1, A3, A4. Whenever during the compilation process, when we are finding the keywords, so it is going to store in a hash table. I think you remember the different data structures you can use to store the, and there are the literals. And suppose there is a variable which is used within the program, that is A5 equal to A4 plus A3. Now, whenever you are scanning or checking for the syntax error, you find three variables, that is A5, A4 and A3. So you need to quickly refer whether all these three variables are defined or declared. Let us say assume that these three are integer variables. So we'll immediately need to confirm or we'll hash to the location number 0. Let us say first alphabets goes to location number 0, but I am finding A4, A3, A1, A2 and A, but A5 is not defined. So it display with a error message that this particular variable is not defined. Or if you are working with a intelligent compiler, it will take your permission to add a statement that integer A5. Okay, so this is a simple example because if you recall your compiler, we talk about different data structure that is used in where your symbol table. So if you remember the section symbol table, so hash table is one of the data structure. Okay, so here again I repeat, in dynamic hashing, number of buckets are increasing or decreasing, even increasing or decreasing depending on the number of identifiers that entered into the table for storing. But in static hashing, number of buckets are fixed. But in case of hash chain, we can have a dynamic, I mean, number of slots are dynamic that increases with the element that entered into the hash table. You see, if you look into the address number 1 or address number 0, because I do not have a variable that starts with B and C, so I am not reserving any space. So in another way, it is a better storage management. It is compared to the other hash tables where we fixed number of buckets and number of slots in advance. I repeat again, number of buckets are fixed, but slots are dynamic in nature depending on um, how many variables are entered or how many variable you are going to enter. That is your n. And they are the formula we are using to identify the loading density n by SB. That concept is not here. Here the number of identifier and number of nodes are identical. You can say we are reserving only 26 slots just to store the address of the next nodes, but we store, if there are n number of locations, we only store n number of node that can accommodate maybe more information, maybe you have one more field with this particular node which carries the information. Okay. So you look into the very simple formula, the average search length. The average search length is a calculation when we are looking into number of element which is available. So based on that, we can calculate the average search length, and depending on the number of elements, we can find out how much time it will take. If you calculate the number of elements, here is 1, 2, 3, that is in first line you have 5 variable. Next you have got 4 variable, 9, 10, 11, 12, total 12 variable, n equal to 12. Average length calculate, and if you to the number of nodes that is being used, first location, second location, third location, fourth location, fifth location, sixth location. So these 6 locations are in only in used. Then we have number of nodes that is associated with each location. Number of nodes associated with each location. So we find out the average search length or average time required to search a particular item. Similarly, if I'll ask how much time it will take to insert, if it hash to a particular location that have no nodes, then it takes a time that, and also if there are multiple node also, that takes the same time, because in both the cases you need to acquire a node. Let me clarify. You have to enter one variable called d1. When d1 is to be inserted, then it has to the location number 3, and you found that one variable called d is already stored there. So you have to acquire a node. A free node is there which holds the information about d1, and it may be located at any memory location. That has to be added to the list that starts with the address 3. Is it clear? Because if you remember a simply linked list operation, we have a free list from where we need to acquire a node. That means whether I am inserting to or to a chain, the insertion time is constant, because the time required to acquire a node and how many link updation you have to do. One link updation for existing link field, another link updation is the node which is to be added has to be connected. Either if you look into that, suppose A4 I have added, I am updating the link field available with the table HT. I am updating the link field with A4. So two link field is required for any type of insertion. So you can say the insertion takes a constant time, whether it is added to a list containing 0 element or list containing a few elements. Okay, so the hashing by chaining, so it depends also similar type of hash function. The overflow handling is very simple. No need of again recalculating with a hash function. So once it addressed to a particular location, if the no space is there, just like your table, it directly acquires a node, add it, and the store it into that location. So what is the advantage comparison to the previous technique? Here we don't have to execute a second hash function to do that. Okay, with the one hash function, we generate the address, then we search in the memory to find out how many nodes are there, and we select the appropriate node. Okay, so hashing by chaining operation, as I explained, there is a lookup, there is a insertion and deletion. What I suggest you use your own terminology to write it, maybe search, maybe lookup, maybe insert, and assignment for you to create a abstract data type or write down the number of functions required and representation to implement a hashing with chaining, how it looks like. Okay, so average chain length with n entries that we have seen, because n divided by m, all hash address are chosen with the same probability. That if you look into the example, we have 26 location. So when a variable is entering, it may be started with any English alphabet letter. That means that may be variable with AB or BA or CA or ZA like this. So it is equal probable. So we can say it will be 1 by 26. So based on the number of character and the location, you see the formula what we are calculating, average chain length is n by 26m. Okay, then we calculate the expected number of entries inspected during the failed search. When you try to enter, expected number of entries inspecting during successful search. So successful search, sometimes we write C or sometimes we write CN. So this N actually indicates whether it's a first item, second item, third item, fourth item, it's like this. So the observation or the conclusion is that CN dash, that is expected number of entries to be inspected or number of comparisons to be carried out when you fail to find out the item. When you fail to find out the item, in fact you are looking for a variable, say suppose say as I say A5, you land into the location. This takes a constant time to come into that table, but when you land here for A5 or A6 or A7, you cannot say immediately. You need to examine the existing nodes which have already connected. So this is the time, you can say the time taken for expected number of entry inspected during fail search. So you are searching for A5 or A6, you need to compare all the 5 presenting elements, then only you can conclude that item is not present. So similarly, expected number of entries inspected during successful search, that means first you are going to find out whether it is present, and then you are performing a insertion. So when you are performing a insertion, it adds to 1 unit and the average number of comparison it takes. So we can discuss the theorem proving, but I'm skipping that one. Just remember the formula to calculate the, to the problem. So only two formula will be sufficient. One is 1 plus alpha by 2 and another is your successful search is directly proportional to alpha. Okay, so I have explained you the advantage and disadvantage. So in case of direct chaining, this is the efficiency lookup. Sometimes we take up a particular application where the hashing is a requirement, maybe for a particular compiler, some type of code requires the variable to be defined at a particular place, and we are designing a compiler. We try to take the help of the hash table. If you look into a particular programming scenario, you may find a programmer always declares a variable starts with A or starts with B or starts with C, and another person assume that okay, any variable can be defined with a average. Maybe A will be maximum 10 or on average 10 character, A B is 10 character, C is 12 character. So I can reserve a static table with a number of slot to be 10 or 12 or 15 like that. So there is a stage of the space. And second, here when you are looking into the lookup, and any user are free to define a variable, so that is a better data structure. Okay, so disadvantage, as you have discussed, you are spending one more location for every information, that is a pointer. Okay, so then the collision may takes place. The colliding elements are outside the hash table. Outside the hash table means, suppose here outside the hash table means the nodes that are linked from one location to other. So they call it as a outside hash table. Okay, but still it has an advantage with certain number of elements. If you look into a compiler example, let us say there are set of reserve words, and your compiler need to differentiate between the reserve words and the user variables. As the reserve words are fixed, so you are going for a static table or a closed table. You are going for a closed table. And if we come into the user defined variables, so user can go for defining the variable as for his own choice. So the best choice is that it will be goes to a table where the slots can grow or shrink depending on the number of variable present or number of variables you are defining. So the analysis of separate chaining or this open hashing is most appropriate when hash table is kept in main memory implemented with a standard memory linked list. So Ajay's number of times says ki where this hashing is implemented, it has two possibility, main memory and secondary memory. So open hashing takes place in the main memory. The number of elements per bucket is roughly equally sized when to start with, so that the linked list will be short, and when it is short, definitely it is added to the best to the performance. And if there are n element sets, that means there are any element to be inserted or n key is to be inserted, then each bucket will have roughly n by b. So we can decide the b is the number of buckets, so roughly we can decide it will be equally distributed. Then the average bucket will have only one or two members. So that is the ideal case, but it depends on the program or the user and what variable he has defined. So b bucket an element in a dictionary, or that is the directory service, average n by b elements per bucket. So the basic operation here we talk about the insertion, search and the remove operation, which takes 1 plus n by b each time each depending on the number of query. And if b to be about n, that means b will be equal to n. So if you put up that formula n equal to b, n by b becomes 1. So you can say it takes a constant time. But if we'll say n equal to b, sometimes it may be requires a very large table when n is large. Assuming each element likely to be hashed into the bucket, that is the equal probability any location can be uh, can be used to store. So it says in the bucket running time constant, because hashing function time is directly proportional to running time, and that is independent of n. Because if I am going to insert 1, it may go to any of this location 1 by 26. Then I go for a variable b, then I go for a variable start with a, then with c. All will have a equal probability because it will land to any location either start with a bucket 0 to bucket 25. So worst case performance is directly proportional to the number of element it is present, and for both open and close hashing it will be order of n, because to retrieve or insert you have to read past n minus 1. Let us say all the variables are starts with a. So you store into one location, there are 20 variables stored at a. So when you are about to store the 21st variable, you need to compare all the n variables to ensure that that variable is present. And the similar case is for also retrieval. So when you try to retrieve it, it is a complete linked list. So it is equal probable you may retrieve the second node, first node, third node, fourth node up to the last node. So the worst case performance is order of n both for open hashing and closed hashing. Closed hashing also is similar. Your table is fixed and the identifier for which you are inserting or searching has to compare with the other items. Okay, so though we can summarize like this: the analysis of hashing with chaining. Analysis of hashing with chaining. The worst case is HSS yields the same value, all data set in the list, and behavior as a linear list, because we are only dealing with the linked list of a single dimension and storing the address if the node is present. So average case successful that we have seen, complexity calculated to load factor, complexity calculated to 1 plus alpha by 2. This holds for direct hash chaining. With separate chaining, the complexity is bit of higher. So best case lookup is immediately to the success or the next node. So it will be of order of 1. So that is the objective with which we start the hash. So now evaluation of overflow technique. When we look into the evaluation of overflow techniques, we start with linear probing, quadratic probing, and all those things. Here also the similar approach we are using. We are not looking into the theorem proving. We only assume that alpha equal to n by b. If you look into that, this is actually n by sb. We're assuming that slot equal to 1. So only we have the number of address or number of buckets, that will be b. So we need to remember these three formula. One is for linear open addressing, then rehash random probing and quadratic probing, and for chaining. So this just now we have seen the chaining. Un is directly proportional to alpha and Sn is directly proportional to 1 plus alpha by 2. That Sn represents the successful search, Un represents the unsuccessful search. I think this is the critical slide for the problem solving. Okay, so comparing the average number of the bucket hashes, this is I have taken from the reference of a paper, and maybe people try to introduce new hash functions and try to find out which one is best they are supposed to use on a database or a file that is having 1000 records, 2000 records, 3000 records. So we should not be blindly adapt the type of hash function you are going to use. Rather than you can go for a simulation and evaluate what is the amount of average time or average number of comparisons required, because it will definitely tell you which technique is best for how many key or identifier. If open addressing is used, then each table slots holds at most of the element, therefore the loading factor alpha can becomes greater than 1. Okay, so these experiments, as I say, this is for open addressing, and this is never be greater than 1 because of the loading density, and for external chaining it may be greater than 1. These are the two things to be remembered. So average number of bucket access per identifier retrieval. That means when you are searching, So that will be never greater than 1 in case of open addressing, and for external chaining it may be greater than 1. Okay, so this is sometimes simulated to find it out, or you can do your own simulation. So application, we talk about a number of times, we talk about spell checker, and we talk about the application in compiler. The second point says game playing. The hash table stores the screen position. Suppose you are working on a simulation game, and so that the searching will be fast. Hash function can be used quickly to check inequality. If two elements hash to a different value, then must be different. You see, there is a very simple thing. Suppose there are two integer is a very long integer, and you need to compare are they same. Then it argue that if you try to develop a hash function and those two numbers will be filtered through that hash function, if their address generated is identical, then those two elements are equal. Okay, so this is one way. It says you can check for inequality between the number. So these are the summaries to of the hash table, that is fixed one or the closed one. So always there is a thumb rule. Whenever we decide, we use a linear mode function. We try to always write the mode size to be just like we have tested with that example. We have taken x mode 10. Okay, that's a crude example. Instead of x mode 10, it advised we should take a prime number which is close to 10. Okay, so there are many applications depending on the search, or depending on the type of search you want to carry it out. And then we have the limitations of the static hashing. In static hashing, the function h maps to the search key value to the fixed b buckets. So this is mostly suitable, as I say, if you are working on a compiler, a symbol table is there. In the symbol table, we know the number of variables or the keyword that is associated with a language is fixed, and the user defined keywords are also not in that way very large. It has also got a limited in size. So we are comfortable with a small hash table that comes with the compiler, because those people have noted the average size of the table or the variable a typical programmer uses. Suppose the average size will be found to be maximum. All average programmer uses 80 different variable to write a code for some application. So I'll reserve a table of capacity 100. Okay, that will be fine. But if you look into the database grows with the time. And sometimes even if we are deleting the data, we delete the data from the front end, but the back end we try to return that data. That is there the issues also. So we can say indirectly the database goes on growing. Even if I am deleting because of some application or some security reason, or depending on the requirement which might be needing in future, we are not going to really delete those records. Rather than we hide those records, that these records will not be processed whenever we try to put a query. So that's why the single line they have written database grows with time. If initial number of bucket is too small, again I say, when I say bucket, it is 1 2 3 4 like this. On downwards you can calculate, that is number of unique addresses of the table entries, and the database will grow. If the initial number of buckets is too small, the performance will degrade due to too much overflow. Okay, because if the table size is small, then two identifiers or variable are going to land into the same location. When they are land into the same location, it will degrade the performance, because you have used a collision resolution function to store the second element which collide to the element which is stored previously. So retrieval also goes in that same way. So you have to process one more request. Okay, if the file size at some point of time in the future is anticipated, suppose you can say maximum I have 20 entries, or maximum I can have number of slots also you can fix. So definitely one should go for a static hash table or the closed table. Okay, if the database shrinks, again space will be wasted. So that is a decision again. some management routine has to be added. So if you're looking into this slide and you will be asked to write down a abstract data type, or you should write a logical description of a data structure which supports this thing. Okay, so you will be writing in terms of object notation. So one option is the periodic reorganization of the file that we have discussed. If you remember, the hash table getting doubled when loading density is 70%. So reverse I have not told, if hash table becomes small and there are few elements stored in the table, so then it will shrink automatically. Okay, so if database shrinks again, space will be wasted. So the software what we are using must have that capability. It will scale, it will shrink also. So if the database shrinks, again space will be wasted. So then what we have to do, just like garbage collection in operating system, these things a monitor has to monitor either interval of few hours or either in 2 days or 3 days, so that automatically they can reorganize. Let me tell you, how many of you have come across a command, a defragment? Yes. Any of you have come across a command defrag? Hello?
Yes, sir. Yes, sir.
Yeah, yeah. Why you use defrag in DOS? Your machine could have done it immediately, but why you are using? Hello?
Yes,
So
sir.
we
So
don't know.
when we delete some file,
Mhm.
their only links are deleted, not the
The links
files.
are
So
deleted.
it
Fine.
will.
The links are
Yes, sir.
deleted, but files are there, but the storage space are calculated, reported that I have this much of space. Okay. Then what is the action? If you are
Uh,
not going to do that, who is going to do that? If you are not doing it manually, who is going to do that?
Operating system.
Operating system.
Operating system.
Yes. If your operating system has a routine monitor who that does every day, or somebody wrote a program that if I'm going to start my system, after start of my system of 5 minutes it will do the defragmentation. Okay, so similar things it says, that means what I meant to say, suppose you asked to write down a abstract data type for a hash table, then you must include a function. We always talk about a data structure where we will be including insertion and deletion or the lookup. So now this slide says you have to include how many functions? How many functions to be included? One is periodically it try to collect, same just like a garbage collection, you must have a function called shrinks, because when there many spaces are there, it will shrink. Or maybe you have a reorganize activity, and for the reorganize activity, you need a function. Okay, so we start with a data structure. Simply it requires insertion, deletion, or printing, or retrieval, or like that. So depending on the application, it will add the functions. Now let us come to simple example of for hash table used with the compiler. What functions you should, or what type of data structure you are going to create, so that a compiler designer will take your help. Yes, what are the other functions apart from the insertion, deletion, and the lookup? Yes. Let us say I have a compiler who takes care of error connection also, syntax error correction also. Is it not possible to write down a compiler? Suppose there are minor syntax mistake is there, not semantic, of course. Syntax error is there, it is going to take care of that. Is it possible?
yes, sir.
So how you are going to do it? I told that suppose A6 is not there, right? When A6 is not there, you are able to find it out कि A6 is being used um, as a variable. So you can insert a line integer A6 into your program. So if I ask you to write down the program, which language you will use? I'm coming to a very simple assignment. This is a part of the compiler we'll be using. Let us say I'm looking for a, I'm just reading a program, maybe manually, suppose I reads, and I find out that my variable a6 is not defined. So what I'm going to do, or what I supposed to do? I'll define integer i6. Okay. Can you write a program to do that? So there are many IDs or integrated development environment, or sometimes we roughly call them the editors, has got this capability.
Yes, sir.
Yes, sir.
Yes, sir.
Yes, sir.
Yeah, I'm not able to connect actually. I'm taking you from mobile. So it's not possible, I think. I'll not be resolved because there is a connection problem, broadband connection problem. So it's a request that to tomorrow our scheduled lab is there. So two groups will be definitely there. So what I say, the all the I request all the people to join 9 a.m. tomorrow. Okay, 9 a.m. will finish both static and dynamic hashing because today also I was supposed to start dynamic hashing. Okay, just wait for a while.